Okay, so let's take a look at today's experiments. So for the circuit 1, so the circuit is pretty easy and it is similar to the previous lab, so I'm not gonna use Tinkercad to show you guys an example. And only thing I want to say is, so obviously it is a low pass filter, but be careful about the position of the resistor and the capacitor. If you switch the position, it will become a high pass filter, not a low pass filter. Okay, so for procedure 1, when you're using Tinkercad, when you set the amplitude to 10, then you get 10 volt peak to peak. So just set the amplitude to 10, not set it to 5. And for 3, vary the frequency from 10 Hz to 15 kHz and record the voltage across the capacitor, and you could generate a plot just like this, which the X is a frequency and the Y is the voltage. Okay, and there is another important theory we need to know is cutoff frequency. So cutoff frequency is a boundary in a system's frequency response at which energy flowing through the system begins to be reduced rather than passing through. So the cutoff frequency can be calculated by this formula. So for an ideal situation, we can get the cutoff frequency. We can the low pass filter, this circuit, the cutoff frequency is 159 Hz, and we can find this point 159 on this plot. 115, so zooming 159. Okay, so you could see at 159 Hz, the voltage is 7.06, which is shown on the left lower corner of the screen, 7.06, and this number is equals to 1 over root 2 multiply voltage S. Voltage S is 10. Okay, and for the circuit 2, the circuit is almost the same, but we change the capacitor to an inductor, and switch the position as well. I would like to say is for the procedure 3, the RT here equals to R internal plus R inductor plus R resistors, because the R inductor is about 10% of resistor, but for the circuit 1, we don't need to, we can neglect the resistance of the capacitor as its value is pretty small compared to the 1000. So this is a place you guys need to note. And that's it. That's today's lab.